Let us load the built-in keyboard chip, and here it is. Let's take a look at the HDL code, and we see that indeed keyboard is a built-in chip. And if we look at the chip interface, we see that it's a read-only chip. It has no input pins at all. It has only one output, which emits the value that is currently stored in the keyboard chip. Now, this keyboard chip also has a side effect, which is that the keyboard chip is connected to the actual keyboard that I'm using on my computer, on my real computer. And so will be the setting at your end. If you use our hardware simulator, the hardware simulator is connected to your physical regular keyboard, and if you touch the keyboard, if you press any key on the keyboard, the scan code of this key is going to be emitted by the built-in keyboard chip. So let us test this. And I'm taking my finger now, and I'm pressing the key G, and nothing happens. Well, nothing happens because I have to enable the keyboard. So I do it by clicking this button here. So now let us click G, and I'm holding my finger down. And as long as I hold my finger down, I will see the scan code of G, which happens to be 71, emitted by the built-in keyboard chip, which acts as the keyboard memory map. So I'm lifting my finger now, and as you see, the keyboard chip now emits the value 0, which means that none of the keys of the keyboard are presently pressed. Let's try another key. I'm going to press space. So pressing space, and I see that the scan code of space, which happens to be 32, appears. Let me press down arrow, and down arrow happens to be 133. Let us press a digit, say 8, and 8 happens to be associated with a scan code of 56, and so on and so forth. So this has been a demonstration of how we can figure out which key the user is currently pressing on the keyboard. And once again, recall that if the user is not pressing anything, we're going to see 0.